The Lesner Bridge is located in Virginia Beach, where about 41,000 vehicles cross it per day. The first span was built in 1958 and the second in 1969. Over the years, saltwater has seeped into the concrete and is corroding the reinforcing steel. After inspection, the bridge received a rating of 37 out of 100. This corrosion is resulting in increasing maintenance costs and potential danger. The city decided to build a new bridge with a capacity for 6 lanes of traffic and a pedestrian walkway on either side. A replacement was initially proposed in 2002. The design process began in 2007 and was really pushed forward after the recession started, as the city wanted to have a shovel-ready project for when government construction funding returned. They set it up as a traditional design bid build, probably because the money for the whole project wasn't available, and therefore the project timeline wasn't a priority. They hired Clark Nexon to create the design for $9.8 million. Funding was eventually obtained, with the federal government contributing $11.7 million and the state of Virginia contributing $84.9 million. After a lengthy process of obtaining permits from many people, the project was ready to bid in late 2013. But once the bids came in, several problems were found. The first was that one of the bidders had come in $20 million below the rest. A few days later, they admitted to a mistake in their estimating process and asked to withdraw their bid. The second and more serious problem was that all the remaining bids were an average of $16 million above the estimate provided by Clark Nexon. After investigation, it was found that Clark Nexon hadn't correctly estimated the price of materials, or accounted for the fact that the cost of materials would increase over time. Unfortunately, the engineer's estimate was what the city had relied on when asking for government funding. This cost increase all fell on the city, and they had to shift $11 million more from other projects to fund the bridge. After sorting all of that out, McLean Contracting was selected as the contractor for the project. Construction began in June 2014 for what was expected to be a 3-year project, finished in June 2017. But here too, things went wrong. Weather delays and the contractor's difficulty in putting together the gantry crane used in the project have added up to an 8-month delay as of fall 2016. Based on the contract, McLean Contracting has to pay $3,200 of liquidated damages for every day the project is late, which by this point adds up to close to $1 million. McLean Contracting doubled the number of workers on the project, started working 7 days a week, and bought more equipment to try and make up lost time, but they have less than a year to make up 8 months of delay. The actual construction process was fairly challenging for 2 reasons. The first is that all 4 existing lanes of traffic needed to be maintained during the entire process, which led to several stages of construction. First, the existing westbound bridge is narrowed, making room for the new westbound span right next to it. Once that span is complete, all the traffic in both directions is moved onto it. Then both of the old spans are removed and the new eastbound span is built. The second challenge was that the bridge design, the segmental box girder bridge, is one not commonly found in Virginia. It's something that VDOT wasn't happy about, and they recommended a more conventional design, which would be less expensive. But the city wanted something a little more unique. Each half of the bridge is made of 84 precast concrete segments, which are shipped to the site from Atlantic Metrocast in Portsmouth. These segments are then lifted into place by the gantry crane, glued together with an epoxy, and post-tensioned with steel cables. Then the gantry moves on to work on the next span. The segments have to be lined up perfectly since a lot of different utilities go through the bridge, including lines from Verizon, Cox, Dominion Power, Virginia Natural Gas, and the Hampton Roads Sanitary District. The completed bridge will be 2 lanes each way, but is wide enough to allow for 3 lanes in the future. It will also have a 10-foot wide multi-use path for pedestrians and bikers. The bridge includes aesthetic elements such as a wave design on the retaining walls, blue railings, and a curved design including LED lighting on the piers.